In this video, I'm going to try to show you how to do the lateral acceleration in the Scrambler from a video. It's a video analysis for that. So run Logger Pro on a PC or a Mac because it doesn't exist on Chrome yet, right? And then go Insert Movie. And then what you want to do is go browse your way to where the actual file is. I put mine in a folder called Oaks Park stuff, right? And I think it's this guy, the Scrambler at the Edge, right? Yeah, that's the one. All right, and what I like to do, I like to make this thing as big as I can. I feel like that makes it more accurate, but you know what? I don't really know if it does. Okay, so then we're going to go to Oaks Park. Whoops, Oaks Park. Here it is, right? And let's find the Scrambler. We have some distance references. Okay. The back of a car is 1.24 meters. Do we want to use that, or do we want to use the 4.45? I just don't know. I'm going to use the back of the car. 1.24 meters. 1.24 meters. So let's. There it is. See it right there? That's 1.24 meters. So the toolbar is right here. First thing we're going to do is we're going to set the scale. Drag across that. And that is 1.24 meters. Ta-da. Okay. And then what I want to do is find a car that goes out. I'm looking at this one right here. This looks like a good one here. And comes back. That looks good, doesn't it? I think I can make that work. So I'm going to use this car right here. Okay. So I'm going to click on that. And there. Really, I'm just looking at the X acceleration, so I don't really worry about up and down. And I'm actually just clicking with that vertical crosshairs, the bottom part of that. That's kind of fun, isn't it? You're really flying. All right. That should be good, right? So I've gotten one of these. And you might want to do 2 or 3 of these where they get out to the side. And you just track them out and back, right? Now, let's click on this. And what it is actually is the X that we care about. We don't really care about the Y. So let's look at the X in this case, right? And there it is. And so this is, we go out and then we come back. Strangely, we sit still there. I don't know if that's an artifact of our perspective, right? So select this. This is our data. And then click that, see that little curve fit button. So it's 1, 2, 3 buttons from the right. Do that guy. And then you want to pick the AT squared plus BT plus C. This will give us a coefficient. So let's try the fit. Okay. Now, this is fun. Look at this, right? So this is, I'm just going to hit OK, and we can talk about this. Okay, so if you take a look at this, the formula for displacement with acceleration is 1/2 AT squared. Like S is 1/2 AT squared or X is 1/2 AT squared. That's a lowercase a, that's the acceleration. So see this A right there? That A equals 1/2 little a. Okay, that coefficient there is half of the actual acceleration. So this thing right there, okay, that 4.313, that is half of the acceleration, negative 4.313. So 2 times 4.313 is equal to 8.626, right? So that's saying that sideways acceleration is 8.626, right? And you might get different results from different angles or like this, but that's just crazy, right? That means that a full g of acceleration is 9.8 meters per second squared. This is most of that. It's most of a G, right? That's why the person that's inside of you crushes you, right? Okay. So again, the formula is 1/2 at squared. That a there, that capital A, which is not acceleration, is actually half of the actual acceleration, right? That's 1/2 of a. So if half of a is 4.313, then all of a is 8.626. It's actually negative in this case because we're accelerating to the left. So that's what you want to do for the scrambler. Okay, is look at that lateral g-force. Now I know there's going to be some axial g-force, but without an aerial shot, I think it's kind of hard to pick that off. We could. It would be cool if we could get like a camera above the scrambler, but we don't have that until we have drones, and even then we wouldn't do that because it'd be too dangerous. Anyway.